Hey guys and gals. Hey, welcome to Unit 4 in Java. Let's start out with something called a block of code. We always want to be able to break things down into sections. We did that with classes. We'll continue to do that. We used some encapsulation, but I want to show you something pretty simple for the start. We can break different sections into different code blocks. I want you to imagine here is our opening class, and I'm going to draw right here, and of course it ends down here. This is our opening class. That's not a block of code yet. And like all programs do, we have our public static void that are executable. This is the open brace. Let me just switch colors here so you can see this. I'm now going to start here, and it ends down here. Okay. So far, nothing is new. The screen, it would print in main block. So the execution, it would print, we're in the main block. So think of this red area as our main block. Now, we now get another set of braces. And notice we're not in a method, we're just in a block of code. We're going to call this A block, our first inner block. And notice, the only thing we want to make sure we do is make sure that this brace right here closes without overlapping another block of code. So this is going to be our A block. So we have our class, our main block. We have our inner block called A. And notice there's another one down here. Let me switch colors. Oh, we'll go get super colorful here. Our next block, I'm going to call it block B, starts here, but it finishes up way down here. So these lines in between technically start here with block B and with B. So let's put a B there. Got a little rainbow coming on. So let me go over so far what's printed. And we said in main block, it printed out in inner block 1. And then there's in inner block 2 or B. And then notice yet more, I'm going to switch colors again. I'll go with green. There's actually another block called C that is inside of block B. So as long as they're nested inside of each other and don't overlap. Do you notice none of my sets of lines overlap with each other? So after it would print in main block, in inner block 1, in inner block 2, block inside inner block 2, and then it would end. Make sure that you really watch your braces, that they align with each other, that you don't have them overlapping. Look at my hands right now like this, because then the block of code. So why the block of code? Sometimes it's just to really organize. And soon in Unit 5, we're going to be starting with loops and while statements and if statements soon. So we're going to need to understand how to open and close a block of code. Now that we understand a block of code, and let's look at this example. First of all, the yellow highlighted statements are right now commented out. So we're going to use them later, but they're there. So first, let's look what blocks of code we have in this next product. We have, next, we have our outer class. And then we have basically two blocks. We have an outer block. Let me switch colors here. So we have our outer block right here to right here. And we have an inner block. So let's look at that. The inner block goes from right here. And let's double check, is everything, there's no crossing of the block. So that's good, they can't interlace. Now, we're going to talk about the scope of the variables in these different blocks. We're going to look on the outer. We're going to call this the outer one right here. And we have right here this inner. So let's look at, we come across in the outer loop that age is 30. So I'm going to switch the colors back to pink So we can do, we know in the outer loop that age has been established that the person is 30. Got it. Now, the rule is in an outer loop, if you declare a variable, that variable is seen by any inner loop within that program. The scope, in other words, age is seen throughout everything within it. So all the nested loops can see it. So good. So when we come across the first print statement, it prints outer before block, age is 30. Okay, so far so good. Let's head into the inner block. I'm going to switch my colors right here. Let me make it a little easier for you guys to see. Let me make it blue. So now we're in this inner loop right here. And we say weight is now going to be an inner value for that inner loop right there. And it is assigned to 175. So right here, int weight is 175. So 30-year-old is 175 pounds. We're ignoring these two commented out statements. And we now say, well, the inner age is, does it know it? Yeah, it does know it. So it knows it is 30. And of course, it knows that in the inner loop that the weight is 175. We just declared it. Now, age gets switched to 22. Does it change it? Yeah. It's going to come over here and change that value to 22, so it's no longer 30. If an inner changes, it does change the outer value. And we now print out systemout.println, inner after assignment, age is 22. Now we leave the inner block, now we're in the outer lock. System out println, outer age is 22. So let me uncomment some of these items. I'm going to come right here and take away this last system out println and go through the program one more time. So at the beginning, age is 30. It prints outer before block, age is 30. In the inside block, we assign 175 for weight. It prints out inner age is 30. Inner weight is 175. We now change age to 22. It's changed permanently in the outer block as well. And it prints inner after a statement, age is 22. It comes out of the block, outer age is 22. But look at this. It says system out println, outer weight plus weight. Remember what we just said, that if you assign a variable in a block of code, in other words, you declare it for the very first time, weight is 175. The outer block does not know about it. It's just only seen within that inner block. So if I try to run this, you know what will happen? I'm going to get an error. And let me prove that to you. So now I'm going to open this same piece of code. I've uncommented this. And now I'm going to run it. And look down here, error. Cannot find the symbol. It can't find this weight. It doesn't know line 17. So because weight is assigned in here outside of that block of code, it doesn't know it. We call that this, it's out of scope. It can't be seen. Let's try a little bit more. Let's now say, I'm going to re-comment this statement because it won't work because we do not know weight outside of the inner loop or in the inner block here. So now let's try this. I have already assigned int age 30. Don't forget that outer block is also can be viewed and seen in the inner block. Now let's say I go inside here and forget that I've assigned that. And now I'm assigning int age is 45. Now we're trying to declare it here. We're not just changing its value like this did. We're trying to declare it all over again. Let's see if it's going to put up with that. So now when I run, I have an error here. It says variable age is already defined in the method. So you can only declare the variable once. Now you can make a change to it. But now once I fix all this stuff and run it again, I get outer block, age is 30, inner age is 30, weight is 175, age is 22, age is 22. So I hope you're starting to see what scope of a block of code does to that variable. So once again, a block uses opening and closing curly braces. You can put a block entirely within another block or entirely outside and separate from another block, but they cannot overlap. So the types are outside blocks, inside blocks, or outer inner. And when a block is entirely within another block, we call that nested. So now let's just look at this one more time. We can kind of see what these variables are. And when this outer block, a number comes into existence, the outer block knows that. But then if we have another number come into existence, it's only known within that inner block. This outer block is seen everywhere. So be careful that you don't have a variable from the inner block that's in the outer area, or it will not be known. You sometimes find out the hard way when you get these errors. So when I say scope, it's the portion of a program within which you can refer to a variable. So where can we see that? When it comes into scope, we say a variable comes into existence. When it goes out of scope, the variable ceases to exist. And the reason we need that is we want to make sure when we pass our investment from the bank that we were investing in to this other firm that they don't change anything in our permanent variables back in our piece of code, that they have their own scope variables. So be careful not to redeclare the variable. You cannot declare the same variable name more than once within a block, and that's an illegal action. So for example, let's see that one more time. We have a value 35. We cannot assign it again, either here or in here. So be careful. So this line wouldn't work, nor would this line work. So be careful that we don't have that. Override, that term occurs when you use the variable's name within the method in which it's declared. The variable takes precedent over any other variable within the same name in another method. So it changes it, just like we were showing before. Okay. This, I find, stop the video once in a while and kind of really look at the example we're showing you here, because sometimes it gets a little confusing with all the call outs. So let's look at this one. We're going to look at something called overwriting a variable. In the main, we have a number has been set to 10. So this a number was declared in the main method. Good. And if you were to print in the main method, a number is, it would come out to be 10. We now have a method call. So it's no arguments. So we're just passing, we're looking for first method. So it comes down to this block of code called first method. And we now have, int a number equals 77. This a number resides at a different memory address from the one in main. Why is this different than what we just looked at? Before, we were just looking at blocks of code. But now we're in completely different methods, and that is different. So when we assign a number in the main, think of it, it has a separate memory location of what it remembers. And inside here, it has its own separate memory. And you could actually use the same variable. Probably not a good style. It's confusing. But you are allowed to reuse this variable because whatever is in a method has its own scope, unlike our typical plain block. So we often will call this overwriting a variable because we're declaring it both in a different memory address from the one in main. So this is declared locally just within this method. So if you asked, it would say in first method, a number is, and it would actually print out this 77. Don't forget, when we finish this first method, it comes back to the line right after. So now the system prints back in main. A number is still 10. It retained its value. It didn't see this method whatsoever. It's unlike the blocks that we talked about earlier in class. And now when we call second method, we're passing an argument, if you remember from last chapter. And that argument down here in the called method is called a parameter. We're passing the number 10 down here. This A number also resides at a different memory address from the one in main. So it is also now declared locally. Even though we passed down 10, it now has its own little memory just for second method. So if we print out in second method at first, A number is 10, we got passed down. But now if we change this local variable just to second method, even though it has the same name, to 862, it's going to print out here 862. When it leaves this second method and comes back up here to main, back in main, A number is still 10. Is that making sense? So blocks of code are different than methods of code. And this is called overwriting a variable because we're using it again in other places, but it's making a second local and a third local of that same variable. Really look at this a few times or listen to this a few times to make sure you understand that, because that can really throw you off. Now, to make sure you know what you're talking about, go back and turn off sound from that last example and look to see if you would have gotten this correct output or not. Good way to know if you're really understanding this. Next, I want to give you an example of maybe why you'd want to overload a method. What overload a method means is to reuse the same method name in multiple methods. Let's first look around and then understand why we'd want to do this. So of course, right here from here down to here, we have our main method. Notice we have a second method right here called compute price. Important to the story, it has one single variable being passed in as a parameter. We have a third method called compute price. Do you notice something? This one's called compute price. This one's called compute price. And let's look ahead. This one's called compute price. When we use the same method name repeatedly, we call it an overload the method. So how this works is, if you're going to overload methods, one of the methods should only have, let's say, one parameter coming in or one argument actually coming down. And this one, notice, has two parameters, and this one has three. So what's going to happen is, if when the method is called, it has a single argument, it will do this one with a single parameter. If it has two variables, that's an int and a double, it will do this one. And if it has three, we'll do this one. So let's kind of look how this works now. So we work at this little company. We've ordered some online items. Okay, maybe we're ordering from our local J. Crew. Although I hear J. Crew's not doing great. Sorry. So let's say we've ordered 10 items, and unlike J. Crew, they cost $4.75 each. And the coupon value, if they have a coupon, is $2.25. So that coupon gets subtracted from the amount of their order. So first, it says that someone has ordered a case with no discount. So what we're going to do right here is we're going to call compute price. You say, well, I thought if it had a return value, it had to have an equal sign and a variable in front of it. It doesn't have to. That's how we typically do it. But if you're just going to use it the one time, whatever it returns will print here. So let's think this through. We're calling a method called compute price. We have one argument. The argument is $4.75, and we're passing it. Price each was the argument, but it's going to go to this one. Why? It has a single one. And that makes it kind of easy that way. If they have this one, they know just to go down to the single one. So now we're going to find out, oh, here's a constant. We haven't seen one of those in a while. How do I know it's a constant? All capital letters, and it says final in the front. So this means this can't be changed. So a case is always 12 items. That's at least how it's typically done in this company. So case times this 475 would be multiplied out. That value would be assigned to total. And then the total comes back and prints right up here. So let's see. Right now, that would be $57. So line 8 printed out the words case ordered, no discount. And line 9 printed out the 57. So notice print and print line. So that makes it go to the next line. Let's see what line 10 does. It's now going to print out items ordered. So it prints this number 10 in the second line down below. Items ordered dash no discount. So it prints this because it's a print line. It does not go down print. It does not go down to the print line. Line 11 now puts a space and calls compute price. Remember, that's the same name. But because it has two arguments, items ordered, which is 10, price each was $4.75, it's going to go to line 21 because it's looking for the same compute price, but when it has two parameters down here. So we now have items double price. So we multiply 10 items by the price, which is $4.75. That's $47.50. So when it comes up and goes back to line 11, it actually prints out, in this case, $47.50. Hey, let's go to line 12. It's going to do now 10 items ordered with a coupon. And now we're going to call compute price in line 13, but now we have 3 arguments. So it's going to match up with the overloaded method that has 3 parameters. Int, double price, and double discount. Notice those variables get changed to the parameter names. We now multiply the items times price, so 10 times 4.75 is $47.50, but we're subtracting the coupon value, which is now called discount down here, of $2.25. So the total comes back up to line 13 and prints out $45.25. So you can use overloaded methods. Sometimes it just makes it easier based on whatever you need to do when you're running with multiple variables, not knowing how many variables you might have. Let me show you another way you can overload a method, but you can run into trouble with this. So that's why this is called ambiguity. So let's start out. Answer 1, 2, and 3 are all assigned to 0. And notice this. I don't know if we've ever assigned multiple doubles, which is totally cool as long as you put commas between it and you refer to each variable. Good. Now, here we have answer 1 is going to be the received variable that comes back from our method call here. We're calling a method called multiply, and we're passing 2 values, 4 and 6.2. But notice, we have 2 multiply methods, and unlike the last program, they both have 2 parameters. By the way, that's legal. But one of them, they have to be different data types if they're going to both have 2. So we have int a, double, and then we have double and int. So in other words, when this is an integer, which 4 is, and when this is a double, it looks at these 2 and goes, I'm supposed to use this one because I've got an integer and this is a double. So it's pretty smart. It comes down here and it says, okay, answer is a times b, so 4 times 6.2. That double is return because it's double is the data type for return, and comes back to answer 1. Okay, so right now, everybody, answer 1 is set to 24.8. Hey, next, we go to line 7. We have another method, but it's the same name. But this time, multiply is sending down 5.3 and a 2. So it's sending a double and an int. So it finds this one in line 18 that goes, hey, I got a double, I got an int in that order. So it comes down here, multiplies 5.3 times 2, and returns this answer to answer 2. And by the way, that's 10.6. Ignore 8 and 9 for right now. We'll get back to it in a second. Those are commented out. So right now it prints answers are 24.8, 10.6, and 0. We don't have an answer 3 yet. But let's say I try to make an answer 3. So I'll take this out of commented land into real code. Notice I'm trying to call a method called multiply, but with 2 integers. Well, let's see if it likes that. I go to run and look like it says, this is ambiguous. What it's trying to say is, I don't know which one to go to. If you would have given me an int and a double, I would have known what to do, or a double and an int, but 2 integers? And just so you know, if I put 7.2 and 9.8, 9.8, let's see if it's ambiguous, because that's 2 doubles. Let me run again. So I try to do that, and it goes, nope, yep. That is ambiguous too, because it can't find, no suitable method found for double-double. So this is why that call is ambiguous, and you wouldn't want to do that. So let me introduce a new term, constructor. It's a special type of method. Let me go ahead and show it to you. So I want you to imagine we have our main class, main method that's going to call this test. So we have a second class that we've built called test. If you ran it without this from here to here at all, in other words, you just wrote class test, left curly brace, end curly brace, and run, the computer, the compiler, will create a default constructor. And what this means, it's a constructor that either has no parameters, notice no parameters, or if it has parameters, all the parameters will have default values. So if there's no constructor in a class, the compiler will automatically create a default constructor. It wants something inside this class. Notice it uses the same name as the class. So this was a class name test. It says, well, I'll just have a test method. We call this the default constructor that the compiler built. And I can just write here, the default constructor invoked it. So it threw it inside. Now that we understand that, so if I was making this class called employee and I compiled it, it would automatically create this constructor, although it wouldn't have this inside of it. I could now use this constructor. It's an empty item. Maybe I'll put the employee number is 999 in it or something, but I can also use that and overload that method, what we call overload the constructor, and use it again to take maybe one variable, one argument, one parameter, or 2 or 3. So in other words, we can use it. By the way, if you type in your own employee, like down here, and they're already, and it will get rid of, it's the one that it created for you because it already has now an employee class. So if you don't use the employee empty constructor that it created for you, it stays. If you do create an empty employee one that you code, the other one will just simply go away. So next, let's learn about this. By the way, this is a reserved word reference. Look at my screen so you can see what I'm talking about here. So I'm about to do a demo using this, but I want to show you what happens when I do this demo without using this. This, just so you know, will be one of the most confusing codes, so I'm going to really slow down to make sure you understand what's happening. So we begin with a public class, this demo, and it's about the reserved word this, so that's why I called it this demo. We've never used that before. We have our main, so it starts here. We are making an instantiation or the instance of the rug class. Rug class is down here, and we're calling that instance my rug. And we are passing down 2 parameters, round and 68. Round, by the way, is a string, and 68, of course, is an integer. So let's pretend it got sent down here. It finds public rug. It has the correct number of parameters in this method, and it has them in the correct order. Round is a string, 68 is a size. But here's why this is so confusing. Not only do we have a parameter called shape and size, but whoever coded this also has two instance local variables, or that are all throughout this class, called shape and size. Now the computer is going to be confused. Truly, these are two different memory allocations. So when we say assign shape to shape, the computer's like, I don't know what you mean here. Initially, this shape, since we gave it no value in line 4, anytime a string is assigned or declared, it's assigned nothing, what we call null. And anytime we assign an integer where we don't declare what the exact value is, it's 0. So when we said shape equals shape, size equals size, it wasn't sure what to do. So it's just going to use these, it's not changing any of the numbers here. So when we go back up here to say, I want you to call the instance myrug, the method display, object.method, it comes down here and it prints out the rug is null and the size is 0 inches across. You say, well, they shouldn't have written it like this. Well, yeah, I agree with you. But I want to show this term this, and this will help us clear it up. I'm going to go down to line 8 in the code below and type in this keyword called this dot. Notice it turns purple because it is a keyword. And now this is going to help us change this. We'll have to rerun it in a second to see what happens. So let's go back again. We run the program. We have an instance called myrug. We're sending down two values, round and 68. When we come down here, yes, this is round and 68, but we also have these set to null and 0. So now it takes this word round, remember it always reads the right size first, and assigns it to this, in this class, this value, or whatever we're going to assign for this variable, this string. We're going to give it the word round. So it's now changing this from null. It's not confused anymore. It's going to assign that word to round. And now that we passed on 68, it's going to assign 68 to the size used up here. So now we have it. And because these variables are before these two methods, this allows those variables to kind of be global and seen throughout. So now when I call myrug.display, we come down here to line 11, and line 13 does the rug is, and it's going to print the shape, this variable right here, which now has the value of round. Let's run that. So now with my this dot, the rug is round and is 68 inches across. So by putting this here, it knew we were referencing these instance for the private variables up here. Little confusing? Listen to that one more time.